Hello, viewers. In this virtual class, we're going to establish the quotient rule from finding the derivative of a function using the first principle. Here, the function is said to be in a quotient if y is equal to u over v. Okay, u over v. YU is a function of x and v is also the function of x. Given this kind of functions, and we're asked to find the derivative of this function. How do we go about it? We establish the rules, the formula from first principle. We know from first principle here y here can be written as y plus delta y. In this case, our u can be written as u plus delta u. Our v can be written as v plus delta v. Okay, so wherever we see y, this is what we'll substitute. So here we say y plus delta y. Here we have u plus delta u all over v plus delta v. Then the next step is we move this y on the left hand side to the right hand side, and that becomes y delta y becomes u plus delta u all over v plus delta v minus y. If you look at our function here, y is u over v. So we substitute it on the right hand side where in place of y. So delta y here is equals to u plus delta u all over v plus delta v minus u over v. So here the whole of this function, we see here this expression here is a fraction already, and we have to simplify before we can move further. By so doing, the LCM of this fraction is v plus delta v bracket of v. Now v plus delta v open bracket v divided by the denominator here, it will give us v. So v will multiply this, and this will become v into u, okay, v into u plus delta u. Now this same denominator here, the LCM, divide v, what will be left is v plus delta v, which will multiply minus u. So minus u into v plus delta v. Okay, now if we now open this bracket and in numerator here we have this one v times u, that will be u v, v times delta u, that will give us v delta u, minus u times v, that will give us minus u v, minus u times plus delta v, that will give us minus u delta v. Everything over v into v plus delta v. Okay, here we see that uv and they are off, and we will be left with delta y is equals to v delta u minus u delta v all over v into v plus delta v. Okay, and we know that what we are looking for is delta y over delta x. Okay, so we divide both sides by what? By delta x. So divide both sides by what? Delta x. here care must be taken because dividing this one by delta x, it means it will affect the numerator. It has nothing to do with the denominator. So okay, so here we can simply write this as delta y over delta x is equals to v delta u over delta x minus u delta v over delta x all over v open bracket v plus delta v or close the brackets. Okay, so this place this delta x, if we divide this, is going to affect the numerator alone. But here we also apply the principle of limits, that as limits of delta x tend to 0, as the limits, okay, let me squeeze it here, as the limits delta x tend to 0, our of the y delta x here the limit will also apply. Here will become v limit at delta x tend to 0 of delta u over delta x minus v minus u, the limit of as x delta x tend to 0 of delta v delta x all over v open bracket v plus delta v. Okay, so all these limits delta x tend to 0, delta v also tend to 0, and delta u also tend to 0, so that the y, the delta s delta y becomes the y, the x is equals to. So that means if this limit, the v here is 0, here this becomes v du over dx minus u. So this limit will become du ds, not delta x, not delta u delta x again, become delta become dx, become du dx. So here will become u dv dx. Here at the denominator here, this dv becomes 0, so that the whole of this of the denominator here become v square. So that is why the formula for if this function y is uv, our the y over dx is now v du dx minus u dv dx all over v squared. So this is the formula, this is the proof to it. We'll be able to establish why the quotient rule, the formula is v du ds minus u dv ds all over v squared. Alright, so in this is just the procedure. It's a simple method that we can easily manipulate on ourselves. So please, in our next class, we're going to also establish more of this formula from first derivative, from the first principle. Okay, please, all you help me subscribe and also share to other platforms. Have a nice time. See you in my next virtual class.